Today we will do electric field intensity due to point charge in terms of rectangular components. If we look into this diagram here, that means we have a charge Q which is at origin O. So because of this charge Q, it will set up an electric field around itself in this area here, in this region here. So that's why we now we have also a point P whose coordinates is x, y, and z. So we have to find the electric field intensity at this point, that means at point P, along the x, along the y, and along the z. So it will be Ex along the x-axis and Ey along the y-axis and Ez along the z-axis. Now let us write it. Consider a point charge plus Q placed at O. The origin, O is the origin here, placed at O of the coordinate system. Coordinate system of the coordinate system as shown in figure 1. Figure 1 here, shown in this figure. We are to find, what we want here is that we are to find the rectangular components of the electric field intensity let us say E at any point P, let us say whose coordinates is x, y, and z. Okay, so now if we look from this diagram, we have seen that OP, vector OP will be equal to vector R. So it will be equal to, in terms of x, y, and z, we have x and unit vector I plus y with unit vector j plus z with unit vector k. Name this as equation number 1. Now we know that this the magnitude of this vector R. Now R will be equal to the magnitude of vector R, which is equal to root over x square plus y square plus z square, okay, which also can be written as x square plus y square plus z square to the power 1 by 2, because we will need it after some time, so we'll write it this way. Okay, so now we have equation 2. So therefore electric field intensity at P is given by E, which is equal to 1 by 4 pi epsilon naught Q by R square and R cap, and we change this R cap into this unit vector R into a vector R. So or we can write E will be equal to 1 by 4 pi epsilon naught and q by r to the power 3 and r to the r vector here. So we can write it as, since unit vector r will be equal to the vector r divided by its magnitude r, so this r square and this r, it will give us r to the power 3, and here instead of unit vector now we get a vector with this equation. Now then after that we substitute the value of r from equation 1, so or here we have E is equal to 1 by 4 pi epsilon naught. Now Q, instead of R we will write the value of, instead of vector R we will write from equation 1 x to xi cap plus yj cap plus zk cap, then in the denominator it will be x square plus only r, so it will be x square plus y square plus z square for r, but r to the power 3 here, so it will be 3 by 2 there. Okay, so we name it as equation number 3. This as equation number 3. Now suppose if we can write if ex comma ey and ez are the components of E, let us write this side, are the components of E of electric field E along the 3 axis coordinate axis, then we can write Ex, or E will be equal to Ex I cap plus Ey j cap plus Ez k cap. Name this as equation number 3, 4. Okay, so now comparing equation 3 and 4, we have Ex, it will be equal to Ex from here, the I component of all these things, so it will be 1 by 4 pi epsilon naught, Qx by x square plus y square plus z square to the power 3 by 2. Similarly, Ey will be equal to 1 by 4 pi epsilon naught Qy here, then x square plus y square plus z square to the power 3 by 2. Then and you can write Ez, it will be equal to 1 by 4 pi epsilon naught Qz x square plus y square plus z square to the power 3 by 2. Name this as equation number 5. So equation 5 is the required equation. Equation 5 is the required equation. It gives the electric field intensity, it gives the electric field intensity at point P, okay, in terms of rectangular components, because we have seen that in this equation 5 we have seen that we get Ex, Ey and Ez. Ex is the components of the electric fields at point P along the X. Ey is the components of the electric field at point P along the Y, and Ez is the component of the electric field along the at point P along the Z. Now one more thing we note from here, if we look from here, we note that electric field due to a point charge plus Q at O is spherically symmetric, that is at equal distance from the charge. That is, if X is equal to Y is equal to Z, then Ex, if X is equal to Y is equal to Z, then Ex will be equal to Ey will be equal to Ez. So let us write that also. Now if we note that electric field due to point charge plus Q at O is spherically symmetric, that is at equal distance from the charge that is, we can write X is equal to Y is equal to Z, then we will have Ex will be equal to Ey will be equal to Ez. With this we complete the topic today. Thank you.